So yeah, sorry, I need to just record that. So yeah, if you ever looked at a map before, you would have seen something called a scale. Specifically, probably something that looks like this. So in this case here, 1 inch is equal to 24,000 inches, or 2,000 feet on a map, right? Like whenever you look at a map, it's a way to measure distances, usually based off like a centimeter, for example. So this is an example of like a scale would work in a like an atlas, for example, like at the ones that we have at the back of the room. So you've probably seen something that kind of looks like, oops, just click that. Probably like something that looks like, oh, don't need that. Too late. Never mind then. My favorite example of scaling always goes down to a movie. Has anyone ever watched this movie, Zoolander? Yeah? It's always this movie is my favorite. It's one of my favorite scenes in the movie. Come on.
Back to the reason that we're really here. Without much further ado, I give you the Derek Zoolander Center for Kids Who Can't Read Good. What is this? A center for ants? What?
Imagine how much they hate.
How can we be expected to teach children to learn how to read if they can't even fit inside the building? Derek, it's just a... I don't want to hear your excuses! The center has to be at least 3 times bigger than this.
So he's looking at like a big like model for a, oh my gosh, this computer. He's looking at a big model for a museum they want to build of him. Come on. And he's like, he thinks that's the thing, right? That's what they're going to build. No, whenever they're doing new buildings, they build models like this, right? Whenever you do maps, they have scales like this. This is kind of the stuff that we're looking about. This is used a lot for anyone who works in construction and the trades. It's a really, if you do anything like with your hands, like, yeah, even like mechanic stuff, like looking at blueprints, for example, maybe if you're like really into technology and you're trying to like repair like a circuit board, you're using stuff like this. Like this is the stuff that exists. And so a lot of it's like logic based. If we just think about it, if we always go back to a really simpler situation with easier numbers, it's going to make a lot more sense, because you're going to be sometimes given some numbers where it's like, this makes no sense. Sometimes you need to take a step back. You need to think about what's being said. So we're going to jump straight into it. Now, I think I've accidentally, if you guys go to this next page, sorry, can you really quickly go to this page here? Is this stuff filled out for you guys on your printed copies on page 4? Darn. Okay, I printed the wrong one. Congratulations. You get one that's a little bit more filled out than I would have liked. Okay, that's fine. Before we go into this deals with a lot of ratios. So this is the same way we've set up our questions for a couple of units now, and how we solve equations, how we do ratios. So I want to do a quick recall of that because it's been a couple of weeks since we've looked at that. So there's one question here. I think this is on the second page. Given the ratio of length to width of a rectangle is 5:3, if the rectangle is 24 centimeters wide, how long is it? I accidentally filled this out for you. Oops. But basically, if the ratio is 5:3, remember we always set it up like this. Left goes on top, right goes on the bottom. If this, so this is length to width, length to width. It's basically saying here, if the rectangle is 24 centimeters wide, how long is it? So we set up that, hey, I know it's 24 centimeters here, so that's why I put it here. And then this is the thing here I'm trying to figure out. Now they put an L here, you can put an X, whatever it is, yeah. But essentially what they're trying to do is, this is an equation that we've dealt with before now at this point. They're trying to figure out a way so that tells us directly what the answer is. So they times both sides by 24, which gets rid of this, and all of a sudden they're left with an answer. So let's really quickly practice one up here. So you have an example up here as to how it's supposed to be done. So let's really quickly practice one of these. This isn't the primary goal, it's just a recall. So if I wanted to solve question 1 here, what would be my first step? There's an X here. My goal is always to get
And black.
X is equal to something.
Multiply by 168.
Multiply by 168, right? I need to get X by itself. This is the ratio. So I need to multiply both sides here. This is on page 2 by 168. And if you do that, so 168 times 3, you're going to get, so 56 over, oh, wait, no, 168 times 3. I divided by 3.
Isn't it divided by 3?
It's, no, because remember, so this is 168 times 3 over 8, right?
Aren't you like going around the question?
So what do you
How
mean?
many 8s can fit in 68?
Into 168? Well, that's not quite it. That's not quite it. We're isolating our value. We're getting X by itself here. So technically, this is the same thing as 168 over 1 times 3 over 8. So what happens is this 168 multiplies into this 3, then it gets divided by that 8. But so essentially what we're doing is 168 times 3, I'm going to get 504 over 8 is equal to just X here, right? Because this is gone. It cancels each other out. So then it's just 504 divided by 8, and that's going to give you your answer, which is going to be 63. So X in this case is equal to 63. So these ratios are the exact same things. I just wanted to do a quick recap of that. I'm going to give you 30 seconds to try out question 2 on your own.
Five over 4 over X.
Sorry, for this one, over 8. Sorry, for this one, push 2. So we times both sides by 168. Yeah. Because we're trying to get X by itself. I think you were on your phone when we were going through it.
No, I was writing it down.
Well, we'll go through question 2. So remember, I see an X here, right? There's an X in this question. My ultimate goal is to get that by itself, right? It's on one side of the equal sign. I don't know which side it's going to be on yet, but I want X by itself is the goal. So in order to do that, I need to get rid of this little 13 here, right? So I got to do the opposite of that. So right now, X is being divided by 13. What's the opposite of dividing? Multiplying. So instead of dividing by 13, I'm going to multiply both sides by 13. So these two things here are going to cancel out, and I'm just left with X by itself on one side. And then over here, I have 7 over 91 times 13. So I take the 7. So this is technically what this is over here. 7 over 91 times 13. Jasmine, just able to put the phone away? Yeah, but don't need to be on the phone, right? So I take my calculator and I'm just gonna put that in there. So 7, oops. 7 over 91. And then take that whole thing, times it by 13, right? All of a sudden, it's gonna be equal to, it's just equal to 1. Yeah. So I'll really quickly give you 1 minute, do question 3 and 4. I'll just pop the answers in there. This isn't the main goal of it. It's just a kind of a refresher here. And Hannah, are you able to see okay? Perfect. Okay, so about 20 more seconds.
Honestly, I think it's a lot easier if you don't just put the.
Sorry. Like,
When you write down the answer
Mhm.
up there, it makes it kind of harder to find that answer.
like you mean you,
Write out the problem,
yeah.
but then you write out the answer beside the problem. It makes-
Like down here.
Like, how do you get it?
Okay, yeah, so for this one here, so remember, my ultimate goal is I want to get, like, you mean, like, don't do this?
No.
Oh.
By all means, just write out the problem. Let's
Okay.
figure out the answer.
Yeah, so x over 7 is equal to 30 over 105. So I'm trying to figure out what I could put up top here to make this like a true like statement, right? Like so one, just as an example, this is the same thing as saying 1 over 2 is the same thing as 2 over 4, just with much harder numbers.
So if I go 1/5 divided by 7. That'll give me my answer.
Not quite divided. So right now you can see x is being divided by 7, right? I need to do the opposite of what's happening here to get rid of this. So instead of dividing both sides by 7, I'm going to times both sides by 7.
So how do I get 1/5?
So just take it like one step at a time. Just focus on what's happening to our x thing here. So I just write my equal sign. So I'm just doing it one step at a time, in which I know I need to get x is equal to something as my answer, right? In order to do that, this divided by 7's in the way. So I need to do the opposite of the thing that's happening there. So instead of divide by 7, I'm going to times both sides by 7. So I'm just focused on the left side right now. These are going to cancel out. I'm just going to be left with x on this side. Now on this side here, all I'm doing is I'm taking this whole fraction. I'm taking this whole fraction, 30 over 105. And I'm timing the whole thing by 7. So I'm just bringing this down. Oops. And if I do that, it tells me I'm going to eventually get the answer of 2. And now for question 4, remember my whole goal is I need to get x by itself, right? I see an x. I'm trying to get that by itself because that's going to tell me what the answer is. Now the problem here though, normally we've had x on the top of a fraction, right? The difference here is x is on the bottom of a fraction. So this is going to be a 2-step equation because I need to get it out of the fraction. That's what I need to do, and it's on the bottom. So what I'm going to do is, right now, 408 is being divided by x, right? So I need to do the opposite of dividing by x. I need to get it outside of this fraction. So I'm going to times both sides by x. So these two things are going to cancel out. I'm just going to be left with, just on the left side, I'm just going to be left with 408. On the right side, I'm going to be left with 4 over 9. I'm going to put a little dot here just because that means multiplication, just because I'm dealing with an x. So this is 4 over 9 times x. So now what I need to do, remember my whole goal is I need to get x by itself on a side, right? What's in the way of me doing that? 4 over 9, right? And what's happened with that 4/9? Well, it's being timed, so I need to do the opposite, which is divided. Yeah. So now I divide both sides by 4/9. To give me my answer. So this is going to be a really weird one for your calculator, by the way. I don't know if we've done this before. So I'm taking 408 and I'm dividing it by 4/9, right? That's technically what's saying here. I bring this down, it goes along this path, divided by 4.9. So same thing, we normally set up our fraction here. So this is 408 and it's being divided by another fraction, which is 4/9. I'll show you a different way of doing it too. You don't need to do it this way. But you see how it's a fraction divided by a fraction? It's really weird for your calculator. It works. It looks weird. And that's going to give us our answer. You could also just take 408 and then divide it by the fraction like this. This also works. Depending on how you want to structure it, that's fine. But either one of those is going to give you the answer. And the answer is, anyone get it? 918, yeah. So in this case, 918 is equal to X. So kind of a weird one for your calculator. So I'll give you a second to get that down.
How is it
Mhm.
you're dividing it when you're multiplying?
Which part? This one here? Oh, like 408 divided by this?
Yeah.
So
But if you're not, if you're multiplying it, why is it multiplying? I mean, if you're dividing it, how is it?
how is it getting bigger? I see what you're saying. So it's a lot of people think, oh, I'm dividing it. It's going to get smaller, right? So what this is technically saying is it wants to know how many 4/9s are going to fit into 918. 4/9 is 0. So how many of these fit in? Yeah. Most of the time when you divide, something's going to get smaller. If it's by a decimal, it's going to get bigger.
So, like. Okay. That's like me cramming 4 midgets in one little clown car, and then that clown car is 2 people.
Probably not the best example. Like if you think about if you think about if I want to know how many quarters are in $5, I want to know how many quarters are in $5. That's 5 divided by 0.25, right? Or 5 divided by 1/4. Like that's a quarter, right? Like that's that.
Why is it 4/9 then?
Why is it 4/9? Because that's just what it tells us it is over here. And then we need to divide by 4/9 to get X by itself.
Makes sense.
So question, so there's a couple more questions on the next page here. Was that page 3? 1, 2, 3, 4, 5, 6, 7, 8. I'm going to give you about 5 minutes to get through as many of them as you can. We'll go through the answers. I'm going to pull this to my screen. I'm going to fill it in and I'll bring it back in 5 minutes. Okay. So you got 5 minutes to go through as many of these as you can. I want you, before you do that though, look at question 9. What's different about question 9? There's decimals. So you need to get rid of those decimals first. Really nice, easy way is going to be times and everything by like 10 or 100 or whatever it is when you're done with it. You need to get rid of decimals in your final answer. But we'll go through that. Okay. So I'm going to give you 5 minutes. Go through as many of those as you can. Here we go. So we always do model to the original in this case. So a scale statement is a ratio that shows the relationship between the sizes of 2 objects. I have 2 objects. They have sizes here. I know each side of this triangle is 6 centimeters of the original. Each side of the model triangle is 3 centimeters. If we always do it model to original, the model is 3 and the original is 6. And then I just simplify that, right? I can simplify that. I see that. I can act 1 to 2, 1 to 2. Because we can divide both sides by 3. We can simplify them. Yeah. But so yeah, you go from 3 to 6, and then you want to try and simplify it in that one of the sides you want to try and get to a 1 usually. Ideally, that's not always the case, but that's usually a good rule of thumb. Now over here, same thing. It's always model to original. Model to original. Like you'll have to memorize that straight up. It's always model to original. Maybe if I spell it right. There we go. So model to original. So scale factor, remember, is a number in which the dimensions of an original figure are multiplied to produce an enlargement or a reduction. Again, we'll come back into that, but they are different things. So when it asks for a scale statement, it's in a ratio. When it asks for a scale factor, it's in a fraction. So in this case, my original is, my model's 3, my original is 6. Same thing. You simplify those both, you end up getting 1/2. This is all on your screen, but just wanted to go into that. Sorry, 9 to 24. 9, yeah, 9 to 18. Yeah, you bet, exactly. Okay, so for question B here, again, you guys have this all figured out, but it's always, again, model to original, right? Model to original. The model in this case, if I wanted to do a scale statement of just this. So now I have a 3D object. All the sides are not the same, right? Just take the same line. Take the same line in an object. I'm going to take the bottom of it, of each one. Boom. Now I have 2 things to compare. The model in this case is 15 centimeters. Okay. Yeah. So the model's 15. The original is 3. It's a 15 to 3 here. Now I can simplify that. They both have a 3 as a factor. So I can divide them both by 3. I'll end up getting 5 to 1.
Which 3?
Sorry?
Which 3?
Oh, this 3 right here. This 3. Remember, it's the same.
Faces or?
Oh, I just took the same line on each of them. So I took the bottom line on each of them in this case. So I see, so this line right here is 3 centimeters, right? And then this line over here is 15. So it's the same line on each rectangle. So this is my model. This is my original. So if it's model to original, it's 15 to 3. Yeah. That makes sense? Yeah. And same thing, scale factor, model to original. My model is 15. My original is 3. I get a 15 over 3. That is 5 over 1. Now what's 5 over 1 equal to?
2 over 10, or
It's a trick question. It's just 5, right? It is equal to 10 over 2. That is true. But you can simplify the 5 over 1 even further to just 5. So the scale factor in this case is it's getting 5 times bigger, right? We took our original, we made it 5 times bigger.
So 5 to every 1.
Yes, yeah. So like if you think about this, like you guys ever gone to like a museum that has like, here's a big thing of a red blood cell. You ever go to a doctor's office? They probably have like a big thing on their table, like a model of something. Maybe it's of the brain, maybe it's of like a cell, something like that. Usually it's a little bit bigger. So this is one of those examples where we're going to take the original thing, something small that's really hard to see. We're going to make it bigger so we can work with it a little bit easier.
So the scale factor is all about like 1 to every 1,000, let's say.
Sometimes, yeah. Like, so in this case, so if we look at our original, our model here, our model is half as big, right? Does that make sense? It's half as big as the original.
So you're just multiplying it?
Multiplying it, yeah. So I'm taking my original, multiplying it by my scale factor. I'm taking my original, which is really tiny, multiplying it by my scale factor, which is 5. It gets bigger. But when I multiplied it by something smaller than 1, a half, it got smaller, didn't it? So that's what the scale factor is. You're taking the original, you're timesing it by it to get your model's size. So now I think you guys don't have this, right? Aha, okay, perfect. Sorry, you do have this one, unfortunately. I forgot to delete a whole bunch of stuff. So let's work on question C here. So before I start with anything, I know I'm working with scaling. It's a what to what? What to what? What was the first thing we put at the very start of every single question? Last one. Close. You're on the right track. It's model to original, right? It's always model to original. So we want to write a scale statement for these and then do the scale factor. So we need to do the scale statement and the scale factor. We're doing two things with each one of these questions. So let's do that scale statement, which is in a ratio, right? Model to original. So let's do that. So model, I'm really lazy, so I'm just going to do M to O. Does that make sense though? Model to original. What's my model? Which one of these two heights is my model?
The original.
Oh, but which one of these two is the model? 2 or 1.2 centimeters, right? Because that's the one in the photo, right? Now, what's my original? What's the size of my original? So you'd be inclined to think that, but not quite. It's 1.8 meters to 2 centimeters. You need to get these in the same units. So this is the same thing as 180 centimeters, right? So now that it's in the same units, it's technically 2 to 180. We want to get into the same units always. So if I do that, I know I can simplify. These are both even. I can cut them both in half. I'm going to end up getting a 1 to 90. So this is my statement. So this is my scale statement. It's a 1 to 90 ratio. But I also need to do my scale factor, right? And that's what we set into a fraction. Now, what goes on top of that fraction, Austin? What goes on top of this fraction for a scale factor or scale statement?
Model. Original.
Model and original, right? Model on top, original on bottom. Now, my model height was 2 centimeters. My originals was 180. And I can also just simplify that, same thing. Now, you can save yourself some work here. You've already figured this out, haven't you? So why don't we just bypass this step? We bypass this step, just go straight to the, you can do this, this is fine. You can just go straight to, and it's 1 over 90. That's okay. You show me your work. That works okay.
So what if we don't show you our work?
And something like this, you could go almost straight to the answer and that would all be fine. You'd probably have, you.
Honestly, like,
Mhm.
I look at like most of the stuff
Mhm.
and I just write down the answer.
You want to show probably at least one line. Like you could just do like 2 to 180 and then 1 to 90. That would be fine.
It's a lot though.
So I want to go to our next question here, question 2. So there's some, what's different about this question, or what, not what's different. What makes this question difficult rather? There's some complexities in this question. There's an X, that's one thing. And what else?
Times it by 4. So it equals 1.
Okay, so you see there's a fraction here. We want to make that to an easier number. That's another one. So we found 2 of 3. What's the third thing that makes this a harder question?
It's in inches to a foot.
And it's in inches to a foot, you bet. So we found the 3 things that make this one a little bit of a harder question in that we're trying to make this in a form of a 1 to X, which means it wants 1 to be on one side. It wants one of the sides to be equal to 1, specifically the one on the left. So first off, I'm going to start with the units. Let's always get the units right first. So it's 1 inch to a foot. We know 1 foot is 12 inches. So 1 foot is 12 inches. Cool. Now we have it in the right units. We're 1/3 of the way done. So right now, let's just put it in like that, in that it's 1/4 to 12-inch ratio. Now, Stephen, you've already said the second thing in that we don't want it as a fraction. So we times both sides by 4, right?
Make it a nice even.
Make it a nice even number. So it's a 1 to a 48 then. Because all you did was you times both sides by 4, right? That gets rid of this little denominator here. 4/4 is $1. Okay. So we've done number 2. Are we done the third thing, which is getting into the form of 1 equals X? 1 equals something? We have, right? 1 equals something. Cool. Yeah. Specifically, 1 inch. Why is it still 1? Well, it's 1/4 times 4. Yeah. So what we? Yeah, I just canceled it out. Yeah. So technically, and if we're writing in the form 1 equals X, 1 inch is equal to 1 inch on our blueprint is equal to 48 real feet. Right? If you ever look at like a blueprint of like your house or a building, it's just on one big piece of paper, right? They'll say the scale, like maybe 1 inch on your paper is 3 feet or something in the building. Yeah, exactly. Yeah. So 1 inch is equal to 48 inches in this case. So when it says it wants to be in the 1 equals things, this is not in that, right? There's not an equal sign there. Oh, something in my nose. Sorry, I'm holding back a sneeze. I hate that when it's just like at the edge. Yeah. Come on. Oh my gosh. Okay, so for question B here, this is not supposed to be filled out, but it is, so whoops. But just take a look at what's happening here. So the length of a room that measures 3 3/4 inches on this blueprint. So this kind of bases your question off here. We already know it's a 1 to 48 here, right? You could set it up this way too. You could set it up in your ratio way if you like it that way better. So what's something that measures 3 3/4 inches or 3.75 inches on a blueprint? You could set it up this way if you wanted to as well. Either works. And so in this case, it's just, 1 times something gave me 3.75. In this case, on the right side, they times it by 3.75. Either one of these works. And that would give you your final answer, which is that X is going to be equal to 180 here. You can do whichever you prefer, okay? You want to put it in fraction? Do it. You want to put it in ratio? Do it. They're the same thing. Now, does anyone know why carpenters work in inches instead of like feet? Why is that?
Metric.
Sorry?
Metric.
It's not that it's metric, but it's easy to convert to metric. And not only that, it's smaller units. You can be a little bit more precise. It's a lot easier to understand, hey, this thing is 40 feet long, than this thing is 4.43 feet, for example. So so if you break it into smaller units, it's easier to get it more precise when you measure stuff.
Yeah, but still, that's cheaters. Only cheaters do that.
Nah.
Hell yeah.
Um,
You see somebody work on floorboards?
oh, yeah, I did that. Did that a couple months ago. Did that myself.
You know what I'm talking about.
So let's I want to go into this one here. Now specifically, this isn't, you've seen this one on a map or an atlas. I want to do this one together. Question 1 here. So reading this question here, the distance between Vancouver and Winnipeg is 1850 kilometers in a straight line. So if you were to, here's my map, don't draw this, here's my crappy map of Canada or whatever. That almost looks like the States, if anything. Screw it. That's my crappy map of Canada. If over here we have, we have Winnipeg, and then over here we have Vancouver. The distance between these two on a straight line That's that 1850 kilometers, right? That's technically what it is. If you were to drive or fly that, that's what it is. On a map, though, they'll use on a map, this distance is only 3.7 centimeters. So they took a ruler to this on a map. That's how big it is. It's only like this big, right? My finger's only a couple centimeters apart there. We want to figure out the scale factor that was used. So first off, my question is, oh, sorry, this is a two-parter. It's a scale statement and a scale factor. So let's just start with the one they asked for first. They asked for a scale statement. Is scale statement, is that in fraction or ratio form? Ratio form, right? If you're ever unsure, just go back to, what page is that? Was that page 4? Scale statement is in ratio form, right? And what do we do? We do model to original, don't we? So model to original. My model is, that's the map scale. On my model, it's 3.7 centimeters, right? Now, what's the length on my original? Sorry? 1850 kilometers, right? Now, there's a problem, though. My units are different. I need to get them to the same unit. Yeah. So that's a really common mistake. And no, most maps, I'm going to be honest, most maps do it where 1 centimeter is equal to like 100 kilometers or something. For the sake of practice, though, we want to get it into the same unit. So, if I have 1850 kilometers, how many meters are in a kilometer? 1,000. So I've now turned it into meters, right? If I press equals here, that's going to give me my meters. So I went from kilometers. If you times that, you're going to get my meters. How many centimeters are in a meter? 100. That's how many centimeters it is. Now, we're going to do, this one's going to be a two-parter in that it's only that many centimeters. So what is that? 185 million. So 185 followed by 6 zeros. 1, 2, 3, 4, 5, 6. Bear with me 1 second. I'll give you a second to write that in.
Okay, what did you guys get?
That's this.
Now,
What do you guys got on the budget?
we'll go up there in a second. So, ideally, what I want to try and do is, if I can, I want to try and get this into like just a 1 to something statement. This is technically the correct answer. That's fine. If you were to do that, if you were to divide both sides by 3.7, because that's what's happening here, right? If I go from 3.7 to 1, I've divided both sides by 3.7. I'm just not writing that down on the side right now. 185 million divided by 3.7 is going to give me 50 million. So my scale statement is, this is a 1 to 50 million scale statement. Every 1 centimeter you see on that map is 50 million centimeters in real life. But this is often going to be expressed because our brain, you can't imagine that number, right? It's too big. It's hard to get a good idea of it. Sorry?
I can see it.
Kind of, but it's still kind of hard. So what most maps do is, even though it's not the correct way, they do normally just put it into, this is 50 million centimeters. So 50 million, so 50, 1, 2, 3, 4, 5, 6. If I want to turn those centimeters into a meter, there's 500,000 meters there, which is the same thing as how many meters go in a kilometer, 1,000, 500 meters. So 1 centimeter on your map is 500 kilometers. Either of these is correct, okay? In a map, if that's correct. You're normally going to have to turn it into the exact same units, though, just so you're aware. So what scale factor was used to make the map? They're going to have it in a 1 Technically, it's the 50 million.
Scale, right?
Yeah, yeah.
Scale to measure.
So that was a hard one. That's why I wanted to go over that one together, just because like it's one of those ones that's really hard to like make sense of sometimes.
Well, if I got that one wrong, I'm like, what the hell? How did I get that wrong?
You probably wrote one too many or too few zeros. That's why I will not give you a question like that on a test, just so you know, just so you're aware. Okay.
You're lying.
Well, sorry, I will give you a question like that. I will not give you questions that make you like convert it to like millions. Maybe you'll have to times it by like 10 or 100 or something at worst. So I want to go into question 2. So this is where, if you remember like our biology, our health studies class in our bio textbook, we saw like photos of like enlarged like cells and nerves, brain cells, like the way things are connected in our bodies, stuff like that, veins. We saw all that stuff in our health studies book. Those were enlarged. They made those bigger, right? They took a tiny photo and they made it bigger. Like, so maybe in our textbook, a human hair was like this big, like, you know, a couple centimeters big, when in reality, a human hair is tiny. So, so we have a photograph that shows a strand of human hair, shows that it was magnified by a factor of 200. So what does that mean? What if I had a hair that was a centimeter big? How big is it actually in the textbook then? It would be 200, right? When it's magnified by a factor of it, it's kind of times it. So another way of thinking about this, so let's do our scale statement. So scale statement's always what to what? Is first off, is this ratio? Or is this going to be a fraction? This is a ratio, right? Scale statement is a ratio. So it's always model to my original. What's my model?
The one magnified picture.
Yeah. Yeah, that'd be the magnified picture, right? So it's going to be 200 and then it's in a ratio to 1. So if it's 200 to 1, it's gotten a lot bigger, right? Our model's bigger because you can't see a hair very good with your naked eye. That's why they make it bigger. Cool. That's my scale statement for this photo, 200 to 1. So now my question is, if the photograph shows the hair as 2 centimeters wide, so now the textbook, it's 2 centimeters wide in your book, how big is the hair? Actually, how big is that hair then? So let's set this up. I know it's a 200 to 1 ratio. I know I have this is already established. We have a 200 to 1 ratio.
Okay, what? Sorry.
Oh, no worries. Thanks for letting me know. So I do my model to my original. So in my model,
Actual width.
we want to find the actual width of it. And it's going to be like 0.00 something, right? A hair is tiny. So I have my ratio and now I need to set this up. So this 2 centimeters wide. Let's do it the way we used to do it, which is where we just set up 2 ratios like this. Is this going to be on the left or the right? The photograph.
That will be on the far right.
You think it's over here?
It'll be 1 to 200.
So it's a model to original. So is this 2 centimeters wide in the photograph? Is that photograph a model or original?
Looking at it, it's a model.
It's a model, right? Like we're looking at a photograph of a hair it's enlarged to be 2 centimeters. So it's a model, right? We're not looking at a hair. We're looking at a photograph of a hair, a zoomed in photograph of a hair. So, okay, now I've set this up. I have 3 things. I'm trying to find a 4th thing, right? What's the actual width of the hair? I don't know. But what I do know is that we did something to this 200 to get to 2. If you look at this, if you're okay with numbers, you'll see that, oh, I took this and I divided it by 100. Some of you might not, like, maybe you'll get numbers where you don't know how to do that. If that was the case, you'd figure out how many times 200 would fit into 2, which would be a 1 over 100. So you times it by 1 over 100. This is the same thing. These are easier numbers, so we can just divide this by 100, which means we divide this by 100, right? To get our width. So the width of the human hair is
Like 0.20.
1 divided by 100, right? So 1 divided by 100 gives me 0.01. So it's 0.01 what? What's our unit of measurement?
500.
Oh, what's our unit of measurement?
Oh.
Centimeters. So the actual hair is 0.01 centimeters wide. Tiny. So we set up our model to original ratio. We know it's a 200 to 1. I know in my model it's 2 centimeters big, so I can use that to figure out how big it actually is. So if you finish that, I want you to keep on trying out, keep going forward here with this. I'll be doing a couple check-ins with some certain questions for a bit, but so now you guys got some little bit of time to practice. I will go through question 3 in about 3 or 4 minutes. Try and set it up. Remember, it's model to original. And try and figure out what that's asking you there.
Why is it always divided by?
Because we're jerks.